Hello and welcome to the CompTIA Cybersecurity Analyst CISA Plus Certification Study Guide. In this video, we will discuss Chapter 7.5, More Vulnerability Assessment Tools. Please like, subscribe, and leave a comment. Software. Examining software for unintentional vulnerabilities has long been considered important. However, today, software and apps are also being examined for intentional malware. While at one time commercial software packages were considered as untainted by malware because they were written by trusted software engineers, that is no longer the case. Increasingly, software programs are being developed by nation-state actors and other threat actors so that the software appears benign but actually contains malware. There are two types of software analysis for vulnerabilities and malware. These are static analysis and dynamic analysis. Static analysis and dynamic analysis. Typically, the software development process involves software engineers writing source code using a programming language that is then compiled into binary machine code. When looking for vulnerabilities, the testing of the software should occur before the source code is compiled. These tests are called static analysis. Figure 7-13 illustrates an automated static code analysis tool. Automated static code analysis may also be accompanied by manual peer reviews in which the software engineers and developers, paired together or in larger teams, laboriously examine each line of source code looking for vulnerabilities. Security testing can also be performed after the source code is compiled, although it is more difficult to find flaws. This is called dynamic analysis or runtime verification, when all components are integrated and running. This analysis is typically achieved using a tool or suite of pre-built attacks or testing tools that specifically monitor the application's behavior for memory corruption, user privilege issues, and other critical security problems. Common dynamic analysis tools are those that perform fuzzing, reverse engineering, and debugging. Fuzzing. Some of the most common dynamic code analysis tools use a process called fuzzing. Fuzzing provides random input to a program to attempt to trigger exceptions such as memory corruption, program crashes, or security issues. An advantage of fuzzing is it produces a record of what input triggered the exception so that it can be reproduced in order to track down the problem within the code. Fuzzing test software consists of an execution engine and an input generator, which usually allows the tester to configure the types of inputs. This is seen in Figure 7.14. A single pass of a fuzzer is unlikely to find all exceptions in software, due to the randomness in the fuzzing process. This is because the mutation of the inputs relies on randomness to determine where to mutate input and what to mutate. Fuzzers require multiple trials and statistical tests. Reverse engineering. How can an organization that has purchased or leased software examine the compiled code to determine if it contains malware? In this case, dynamic analysis can also be used. Instead of relying on a suite of pre-built attack tools to look for vulnerabilities, reverse engineering can be performed. Reverse engineering is disassembling and analyzing a product. A common usage of reverse engineering is to facilitate the maintenance associated with a software program by better understanding how the underlying code functions. Software reverse engineering is often used in cybersecurity to analyze malware to determine how the code works and what its intentions are. Software tools are available to reverse engineer or transform compiled binary code into a text form. A disassembler maps processor instruction codes into instruction mnemonics on a one-to-one basis. A decompiler can also create text from binary code, but the code is at a much higher level and is more concise and easier to analyze. Figure 7.15 illustrates the output from a decompiler that converts compiled binary code in the left pane to a more readable pseudocode in the right pane. A debugger is a tool that can be used for not only tracing the flow of a program, but also for altering its execution. Debuggers can monitor the program's functions and then modify the values of the internal variables, and it can even call functions independently that are not part of the program's regular behavior. Two common ones are Immunity Debugger and GNU Debugger. Immunity Debugger is a tool that is often used to analyze malware. However, it can also reverse engineer compiled binary files so that new exploits can be created. Immunity Debugger boasts that it cuts exploit development by 50% and has connectivity to exploit development tools. Immunity Debugger includes both a graphical user interface, GUI, and a command line interface, CLI. Python commands can even be run directly from the CLI. It can create a standard analysis of the actions of a program. Figure 7, 16 traces variable sizes and how they are used in a program, and can also allow users to modify the contents of variables. Another feature is the ability to provide a graph that shows the interactions of selected functions. This is illustrated in Figure 7, 17. Most debuggers offer only one method to attach to a process that is generated by the application, usually by either the process identifier, PID, or the process name. Using Immunity Debugger, a process can be attached through the PID or process name, but also through services within that process, TCP, UDP ports that the process is listening on, complete binary name, and window name. This allows very quick and easy access to the exact process to be analyzed and manipulated. GNU Debugger, GDB, can debug several different programming languages including assembly, C, C++, Go, and Rust. It runs on many Unix-like systems as a CLI. Although it has no GUI, it does have a text user interface, TUI. GDB was first written back in 1986. GDB uses a system call known as process trace. Through this, it can observe and control the execution of another process. It can also view and change the process's memory and registers. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. Creating a YouTube account is free and takes less than a minute. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. We will see you on the next one.